Hi. So it's a lot easier to show my stuff than it is to describe it, so I was going to start with a demo. Before I do that, let me tell a little story that started this off about 10 years ago. My dad's a doctor. I'm not. My dad is. He's a family doctor, and he was 60 years old, and he decided it was time to go and get him some technology. So he went and bought an EMR. He was so proud of it. It was even before the incentives were out, and he loved it for a week. He called me up one night and he said, "Come down here, I got to talk to you." So I came down to his office and he showed it to me and he said, I used to just pick up a microphone and record all of my, all the medical information. It was minutes. And now I'm having to click tape all day long and it's becoming a clickmare. So he said, "Man, I just want to talk to it." I said, "Man, that's a great idea. How hard can that be?" Well, 10 years later. So do you want to... The patient appears anemic and pale, period. First one's got to start up. Patient's heart rate's 98 and blood pressure's 120/80, period. The patient presents with severe pain and swelling in the left knee due to microtears, limb patella tendon, period. The thing to note here is we're taking a statement, running an LP on it, mapping it to a graph database. An in-memory graph database that has millions of the nodes in it that Applicadia was just talking about. SNOMED, LINC, RxNorm, NDFRT, ATC, CVX. We just went through a rather traumatic experience as we went from 1,700 ICD-9 codes to over 70,000 ICD-10 codes, and you might need 5 or 6 of those for each encounter. But, careful what you wish for clinical decision support, for clinical quality metrics, for evidence-based medicine, for all of these things where we're relying on computational logic to be done on the medical record, we need things like FHIR to provide us a schema. But FHIR also is going to demand, could be 10 to 15 IDs per clinical statement. So an encounter might produce hundreds or even thousands of IDs. So how are we going to do that? Through voice. So here, we've got CDS rules that determine that that's not enough information, that's not enough specificity to ICD-10 code this, so we'll prompt. Bony swelling, dramatic, and it's the first encounter. So here's what's going in the medical record, the statement we throw away. Do a little more. Go to history of the present illness. Fracture in the right calcaneus, period. So here we've mapped that against the clinical model. I'm co-chair of the Clinical Information Modeling Initiative, so that's one of my pet babies. So here we didn't say whether it was intra-articular or extra-articular. We didn't say whether it's displaced or non-displaced. And if I say it's open, then it's going to we've got a wound, so we need to capture the wound information. The thing is that on the clinical topics that you deal with most commonly, you'll develop muscle memory on how to basically make a statement sophisticated enough to push you through as many of the clicks as possible. Because this is what goes in the medical record, the IDs, not the statement. Acetaminophen, 500 milligrams, twice a day for 2 weeks with food is needed for pain, period. Go to review of systems. The lung sounds are normal, period. The patient has a rash on their left forearm, period. The patient's grandmother died of lung cancer 10 years ago, period. The patient had an appendectomy 4 years ago, period. The patient needs a bilateral mammography, period. Now I'll do the nastiest one. I was just at HIMSS, and people come by and want to grab the microphone. And by the way, tonight, if anybody wants to grab the microphone, I'm constantly seeing how well it does. And does it always work? Nope. Nope. But here's the nastiest one I think I ever heard. I've worked to memorize this. The appropriate anesthetics were administered and were further supplemented with 7 cc's of 1-to-1 mix of 0.5% lidocaine plain and 0.5% marcaine plain in the digital block to the left forearm, period. So that's on the medications. If I do it in procedures, the appropriate anesthetics were administered and were further supplemented with 7 cc's of 1:1 mix of 1% lidocaine and 0.5% marcaine in the digital block to the left forearm, period. So imagine how long it would take you to click tape that. The work that I do most often at HL7 is with a group that very few people know about, which is the Clinical Information Modeling Initiative. This is a group that's set out to be able to create standards where detailed clinical models can be captured and shared across all EMR platforms, across research, across everything, and it's going to define schemas. It's going to define the fields, the data elements, and the data types that you need to capture very detailed clinical situations. If you've got an open fracture of the femur, there's a certain set of fields that you're going to want to have that satisfy your clinical decision support chain, your clinical quality improvement metrics, your evidence-based medicine, the research that's going on, maybe the service level agreements that you have between a provider and an insurer. Because if you don't capture the information, there's no way to transport it. You know, at that moment of capture, if you don't get the information that it takes to do the metrics and the CDS, you know, you're pretty much broken for there. So the HL7 SIMI group is creating logical models for all of these different clinical situations that can be reviewed, that can be agreed to, that can be expanded, they can evolve. But be careful what you wish for. It's kind of like the dog catching the car. Because if we build a healthcare system that's dependent on all this information and we have to capture it, and we take one of the most problematic things in healthcare, and that's the amount of time that it takes to capture the medical record for our most valuable resources, which are our clinicians, then the CDS people will be getting what they need, and the metrics people will be getting what they need, but the doctors won't be getting what they need, which is basically to spend less time capturing clinical information. My dad told me a story, basically 1 week into his EMR. You know, he's sitting there two-finger typing, and a patient that had been with him for 20 years came and said, you know, Dr. Freeman, I've been coming to you forever. You know, you're always so nice. You make me feel better. But today, it feels like I'm interrupting you while you're doing your taxes. Yeah. And that was the end of his personal enjoyment and end of his fond relationship with the EMR. The thing is that, you know, if we're going to do the same type of science, if we're going to get at the same kind of assistance at our art that a architect gets from AutoCAD, I mean, if you go to any architectural group, you're going to find that the most important team member, you know, to any project is the computer-aided design software. It can know things, and it can monitor things, and it can calculate things that the architect can't do themselves. And it took them 10, 15 years to be able to take computer-aided drawing packages and turn them into computer-aided design packages. And that's sort of the boundary we're on today, okay? We've got IT systems that capture information, they store information, they process our workflow, they order our goods and materials, they keep our schedules. But if we're going to get the kind of assistance from the systems at the art of medicine, then we're going to have a schema, we're going to have to be able to exchange these things. We're going to have, you know, standardized languages to write scripting in, which is another group I'm involved in. How many people here are familiar with clinical quality language, CQL? Okay. The CQL is a sister standard. It's designed hand in hand with FHIR. Because today, there's no standardized way to synthesize clinical decision support rules and clinical quality metrics that can be distributed to all the different four corners of the earth, all of the different EMR providers, all of the different systems that are involved in a way that operates against standard data and has a standard syntax. Clinical quality language is going to be implemented by any and all EMR vendors, any and all population, you know, pop health vendors, and it allows for a team of people. It could be at Harvard, could be at CMS, it could be at a payer, to basically synthesize the formulae and the behavior and the logic for all of these different scenarios, and then you just load it in a subdirectory and it's going to be executable. So the engine we built is not intended to be a standalone application. It's intended to be an embeddable ingredient into other applications. to basically bring computational linguistics and matching into semi-clinical models and execution of clinical quality language in real time, so that systems can be smarter and so that people don't have to redevelop this each and every time. So this, hopefully you'd never buy anything with my name on it. You'd buy something with stuff that we built embedded into it. Anyway, thanks.